A very good morning, class 10th. In this video lecture, we will discuss our chapter 4 of science, which is carbon and its compounds. So let's get start this video. So first of all, we will discuss what is carbon. So basically, carbon is a chemical element with its atomic number 6. As we all know that we have number of elements in our periodic table and we have categorized all those elements as metals, non-metals and metalloids. And this carbon falls under the category of non-metals, means we can say our carbon is a non-metal element. And there are large number of things in our daily life which are made up of carbon, like we have cooking gas in our kitchen which contain butane, which is a carbon containing compound. Similarly, we use table sugars which consist sucrose, which is again a carbon containing compounds. In fact, all living things, plants and animals are made up of carbon based compounds. So means as a whole we can say our carbon as an element plays a very important role in our daily life. So when we say that our carbon has its atomic number 6, so what do we mean by this atomic number? Let's discuss this one. So basically our atomic number is the number of protons in the atom. So means we can say that our atomic number is equals to the number of protons present into the nucleus. And if we say that our carbon having its atomic number 6, so that means 6 protons present inside the nucleus of the carbon. So similarly, if we have hydrogen whose atomic number is 1, so that means its nucleus consists how many protons? Only 1 proton, because its atomic number is 1. So similarly, if we have an element which atomic number is 8, so that means its nucleus consists how many protons? 8 number of protons are there. And there is one thing more, that our number of proton is always equals to our number of electrons. Means in case of carbon, if we have atomic number 6, that means the number of protons are 6, and which is again equals to number of electron. Means this carbon atom consists of 6 proton as well as 6 electrons. So now let us discuss how these electrons are distributed around the nucleus in discrete energy shells. So this distribution of electrons into discrete energy shells of an atom is known as its electronic configuration. So if we discuss the electronic configuration of carbon atom, so it consists 2 electrons into its inner shell, okay, which is also known as your K shell. This shell is known as your K shell. And its outermost shell consists 1, 2, 3 and 4 electrons. So this shell, this outermost shell is known as your L shell. And this consists how many? 1, 2, 3 and 4 number of electrons. And all these 4 electrons are known as our valence electrons. And all these valence electrons are responsible for covalent bonding in carbon atom. So now let us discuss what do we mean by covalent bonding. So basically the covalent bond is the chemical bond formed by sharing of electrons between atoms. So here we have an example of H2 molecules which is formed by this sharing of electrons. This H2 molecules is formed by the mutual sharing of the electrons of each hydrogen atom. We know that our hydrogen element consists single electron. It consists only a single electron. So these two hydrogen elements take part into mutual sharing to form a covalent bond, and which results into the formation of your H2 molecule. So similarly, let us discuss another example of O2 molecule which is again formed by this covalent bond. As we all know that atomic number of our oxygen is 8. So if we go for the electronic configuration of our oxygen, so that will be 2 and then 6, means its inner shell will consist 2 electrons and its outermost shell, or we can say valence shell, will consist your 6 valence electron. So these 6 valence electron will take part in our bonding. So as per the octet theory, we know there's a need of 2 more electrons because our valence shell consists only 6 electrons. So to complete its octet, there 2 electrons are more needed, because if we have 8 electrons into its outermost shell, then we will say that our oxygen is stable, right? So to gain that stability, we need 2 more electrons. So what it's gonna do, it will share 2 electrons with the nearby oxygen atom. So here what we are observing, that these 2 oxygen atoms shares 2 pairs of electron, which result into the formation of double covalent bond in oxygen molecules. Okay. So similarly, in case of nitrogen molecule, so there is only 5 valence electron into its valence shell. So means there is need of 3 more electrons to attain the stability. Means to complete its octet, there is need of 3 more electrons. So to attain the stability, these two nitrogen atoms share 3 pairs of electrons, which results in the formation of N triple bond N, which is your N2 molecule. So through these examples, we came to know that our covalent bond is nothing but it's a mutual sharing of electrons. So now let us discuss what are hydrocarbons. So basically, the hydrocarbons are the organic compound consisting entirely of hydrogen and carbon. For example, we have ethane, methane, propane, butane. All those compounds consist carbon and hydrogen only. So that's why they are termed as your hydrocarbons. And there are two types of hydrocarbons. One are saturated and another one are unsaturated hydrocarbons. So now what do we mean by these saturated and unsaturated hydrocarbons? So it says the saturated hydrocarbons consist only single bond, means the hydrocarbons which consist only single bond, means there is no double or triple bond between the atoms, and they are having the general formula CnH2n. So if any hydrocarbon which consists only single bond will be termed as your saturated hydrocarbon, whereas our unsaturated hydrocarbons consist your double or triple bonds. For example, we have these alkenes which are unsaturated hydrocarbons. Why we call them unsaturated hydrocarbons? Because these consist double bond. So in case of these alkenes, there exists a C double bond C, means there exists a double bond between these two carbons. Those type of compound which consist at least a double bond or a triple bond are termed as your unsaturated hydrocarbons. Similarly, we have alkynes which consist C triple bond C, means there is triple bond between the elements. Those sort of compounds again termed as your unsaturated compounds. So now let us discuss what are alkanes. So basically our alkanes are the saturated hydrocarbons, means this consists only single bond, and they are having the general formula where your N represents the number of carbon atoms. Okay, so means if you have N number of carbon atoms, so means your hydrogen atom will be 2N plus 2. Let us consider the value of N is equals to 1. So in that case, our hydrogen atoms will be equals to how much? 2N plus 2 means 2 multiplied by, here the value of N is 1 and plus 2. So that will be equals to how much? That will be equals to your 4, means our formula will become C1 and H4, which is your CH4, which is your methane. Similarly, if we consider the value of N equals to 2, so for that case, our number of hydrogen will be how much? 2 multiplied by 2 plus 2, and that will be equals to how much? 6. So means in that case our formula will be C2H6, which is your ethane. Okay, the formula of ethane is C2H6. So in the same way, we have propane in which the value of N is 3, butane in which the value of N is 4, and the pentane and so on. So now let us understand what are alkenes. So alkenes are unsaturated hydrocarbons with double bonds, means these are unsaturated hydrocarbons which consist double bonds, some sort of like this, C double bond C. Okay, that will consist a double bond, and they are having the general formula CnH2n. And moving to the next one, we have alkynes. These are again unsaturated hydrocarbons which consist triple bond, means there will be a C triple bond C between these atoms. Okay, and they are having the general formula CnH2n minus 2, means if you have n number of carbon atoms, so your hydrogen will be how much? 2n minus 2. And there are few examples of these alkynes. We have this ethyne, propyne, butane, pentane and so on. So students, now let us discuss what is homologous series. So here the word homo means the same, and we have one term series over there. So means this homologous series refers to some kind of sequence which consists some kind of similarities among themselves. Let's move to the definition. It says a series of compound with similar chemical properties in which member different from one another by addition of CH2 group is called homologous series. Let us understand it by an example. So in homologous series, there is a general formula of each and every series. For example, if you are making homologous series of alkanes, so they will be having the general formula. If you are forming the homologous series of alkenes, so they will be having the general formula CnH2n. For carboxylic acid, this particular general formula you will be using, and for ester, this one. So means as a whole, we can say that every homologous series consists of general formula. So here we have few homologous series. This particular series is of alkane, this one is of alkynes, and this one is of alcohol. So for alkanes, so we know every homologous series have a general formula. So for case of this one alkanes, they will be having the general formula CnH2n plus 2. Similarly, this alkyne series will be having its general formula CnH2n minus 2. Similarly, this alcohol homologous series will also consist a common general formula. Okay, here the first member of homologous series of alkane is methane, second is ethane, third is propane, and the next one butane, and so on. Okay, and we will observe one thing, that between these two successive members of the homologous series of alkane are different from one another by CH2 unit. Mean if I add CH2 in this CH4 group, so we will get this ethane. If I add this CH2 unit in this one ethane, so we will get this propane. Similarly, if I add this CH2 unit in this one propane, so I will get this butane. So means as a whole I can say that every successive member of homologous series is different from one another by CH2 unit. Okay, so similarly in the case of this homologous series of alkynes family, if I just add CH2 unit with this first member which is ethyne, so I will got what, this second member which is propine. Again if I add this CH2 unit over this propine, so I will get what, this butane. So and similarly so on, and same in the case of alcohols. So I hope this concept of homologous series is clear to each and everyone. So now let's discuss few characteristics of this homologous series. So its first point says every member in the homologous series can be represented by a common formula. As we have seen in these cases, these alkanes, the homologous series of this alkane consists of general formula. This series of alkynes have its general formula, and this of alcohol series has its particular general formula. So yes, we can say that every member of homologous series represented by a common formula. They have a common formula, or we can say general formula. Second thing, member of the same homologous series can be prepared through a one common method. And its third point is every member differ from other by the group CH2 which has the relative mass 14. So as we have discussed here that each successive member is different from one another by CH2 unit. So the same point is concluded over this line. Okay, and the last one is member of the homologous series have a same chemical properties. Means all those members of the homologous series having the same chemical properties. Okay. Okay students, that's all for this video. I hope now you came to know that what this chapter all about, and thank you for listening me.